Welcome to Mathematics. So in this video, we are going to tackle on application of linear functions or application of functions, talking about linear. Okay, so in this video, you need to remember this slope-intercept form, okay, because this is the most usual method to be used in applications of solving linear functions. But you should also remember that this is not used always, okay? So it is mostly used, but it should not be always used. It should always be depend on the problem. Okay, so basically, our slope-intercept form, our M here, so when we talk about problem solving or word problems, our M would be the slope, so it would be moving or changing, okay? So that would be your Q if that particular number is a slope or not, if it is moving or changing, okay? And if it is not moving, it is constant, and that would be the initial amount, that will be your y-intercept or your b, okay? So bear that in mind, okay? So for our first example we have here, let's say a particular plant's growth is directly proportional to time, okay? So it measured 2 centimeters when it arrived at nursery, and 2.5 centimeters 1 week later. Determine the function and graph it. So actually this is the problem. Okay, so it would not fit if I would like, okay, alright. Okay, so it says here, okay, so I'm going to write y equals mx plus b. Okay, so first let us determine within the problem which one of those is not moving. Okay, so we are trying to look for the y-intercept. Okay, so it says here that it measured 2 centimeters when it arrived at nursery, which means our 2 centimeters there is our constant. Okay, so our b would be the 2 centimeters. Okay, how about our m? Okay, let's see. When it arrived at nursery, and 2.5 centimeters 1 week later. So after 1 week, it grew 2.5 centimeters. So our 2.5 centimeters there obviously is not our slope. Okay, so okay, let's see. It says here that when it arrived, it is 2 centimeters, and 1 week later, it is 2.5 centimeters. So if we are going to find the difference between them, it would be 0.5, which means it grew 0.5 centimeters. Okay? So in this particular plant, every week it grew or it grows 0.5 centimeters. Is it moving? Okay. So that will be our slope, 0.5. Okay, so we are going to substitute that with our equation. So we will have 0.5x plus 2, okay, mx plus b. So we are going to graph it. So our y-intercept is 2, so we are going to start with 2. And our, we have here 0.5. So we have 0.5, remember that rise over run, okay? Rise over run. So we are going to rise 0.5 units and run 1 unit, okay? So you can do it again. Rise 0.5 units and run 1 unit. Okay, so you can connect that, and this will be our equation. Okay, so for our second example we have here, okay, I think I'm going to, okay, so it says here a car rental charge is 100 per day plus 0.3 per mile traveled. Determine the equation of the line and graph it. If 300 miles was traveled, how much is the company going to receive? Okay. So, first, let us try to determine which is which. So, it says here, a car rental charge is 100 per day. Okay, so no matter how long you are going to rent that car, you are going to pay 100 per day. Okay, so obviously that will be our y-intercept because it's not moving, it's always 100, right? So it's 100. Next, it says here that you are going to be charged 0.3 per mile travel. So it's moving, it's changing, right? Because every mile that you will travel, you will be charged 0.3. So what would be the currency? Let's say pesos. So 0.3 pesos per mile. So that will be our slope. So our equation would be 0.3x plus 100. Okay? So we are going to, this is our equation of our line, and we are going to graph it. So I have prepared my graph here. So we are going to start with our y-intercept 100. And we are going to rise 0.3 units. So it's very small. It's not like I'm rising. And we are going to run 1 unit. So as you can see here, we have 20 unit intervals. Half of that is 10. And it's very small, that you can't almost notice it. So our line, our graph would be something like this. Okay, so that will be our equation of our line. Okay, so next question would be, it is asking if 300 miles was traveled, how much is the company going to receive? Okay, so from our equation, we have there y equals 0.3x plus 100. Actually, we can substitute that as f of x. So let's say if we have 300 miles was traveled, so 0.3 times 300 plus 100. So 0.3 times 300 would give us 90 plus 100, that would give us 190. Okay, so that's it. For our next example, we have here a bookstore charges 100 pesos to rent the book and 10 pesos per additional hour. Okay, write the linear equation and determine the cost of renting for 12 hours. Okay, so let's say if this is really true, let's determine which is our slope and our y-intercept. Okay, so it says here a bookstore charges 100 pesos to rent the book. Okay, so no matter how long or how short would be your rental, you will be charged 100 pesos. Okay, so that will be our y-intercept. Next, it says here you will also be charged 10 pesos per additional hour. Okay, so every hour 10 pesos would be increased. Okay, so it means it will change. So that will be your Q and that will be your slope. So your slope would be 10. Okay, so we will have our equation as y equals 10x plus 100. It says here, determine the cost for renting 12 hours. So if this will be our function, and 12 hours will be on the rental, so we will have 10 times 12 plus 100 would be 120 plus 100. That would give us 220 pesos. Okay, that's it. Bye.